Hey everyone, welcome back to my channel. I am Neil and today we're diving into quadratic functions, what they are and the best strategies to graph them clearly and confidently. So if you're ready to master parabolas and boost your math skills, let's get started. Please make sure to subscribe because I'll be covering more about this topic in upcoming videos. And if you found this video helpful, don't forget to share with your friends and give it a thumbs up. Thank you so much if you're willing to do that for us. Okay, in the previous video, I taught you how to find the x-coordinate of the vertex using a formula. Now I'm gonna use this formula to help you graph a parabola faster. The formula was this: x equals to negative b over 2a, and by using this formula you can find directly the x coordinate of the vertex. As an example, we have y equals x squared plus 4x plus 1, and I'm gonna sketch the graph of this function. Okay, x equals to negative b, b is 4, a is 1, the coefficient of x, and c is 1. Okay, negative b over 2 times a, which gives you negative 2. Okay, so the vertex has x coordinates negative 2. And how about y? We have two strategies to find the value of y. The first one is to substitute negative 2 into this equation. So negative 2 squared plus 4 times negative 2 plus 1. So we have 4 minus 8 plus 1, which is negative 3. The y coordinate of the vertex. But if you like to use another formula to find y directly, you can use this one. Y equals 4ac minus b squared over 4a. And by using this, you will find y equals negative 3. Okay. X and y of the vertex. So far, so good. For graphing a parabola, we need at least 3 points, and one of them should be the vertex, and 2 other points should be the right side and the left side of the vertex. Okay, so I'm gonna draw a table of value, x and y. The vertex is negative 2 and negative 3. And for finding 2 other points, I'm gonna add 1 and subtract 1 from x coordinate of the vertex. Negative 2 plus 1 is negative 1, negative 1. So if you substitute negative 1 into the equation, so we have negative 1 squared plus 4 times negative 1 plus 1. So the answer is negative 2. And the same story for negative 2 minus 1 is negative 3. So y is negative 3 squared plus 4 times negative 3 plus 1. 9, 10, negative 12, and negative 2. So as you can see, these two y values are equal. And the reason is because a parabola is symmetric. If you move 1 unit to the left or right from the x coordinate of the vertex, the y values will be the same, something like this. This is the vertex, move 1 unit here, the y is here, and move 1 unit to the left and the y is exactly the same because this graph is symmetric. Now I'm gonna sketch this graph. Okay, negative 2 and negative 3. Vertex, negative 1 and negative 2, negative 3 and negative 2. Okay. This is our graph and this is the vertex. And if you like to draw a line of symmetry, this is here. And the equation for that is x equals to x coordinate of the vertex, which is negative 2. So by using this formula, this one, you can find the x coordinate of the vertex and the equation of the line of symmetry. Okay, this is the first strategy that you can graph a parabola. And now jump into another one. The next strategy is graphing by completing the square. Okay, first of all, we should know the perfect square identity, which is a plus b squared is a squared plus 2ab plus b squared. And I'm going to use this for graphing a parabola. For example, we have y equals x squared plus 2x minus 3. If we consider x squared a squared and 2x 2ab, negative 3 is not b squared because it's a negative number and b squared is a positive number. So instead of negative 3, I'm gonna split it out to positive 1 and negative 4. Why? Because if you find the square root of x squared is x and 2x is 2y a times b. So divide 2x by 2 gives you x. So the coefficient of x is 1. So we have plus 1 squared. Okay, but the answer of x plus 1 squared is x squared plus 2x plus 1. So we need positive 1 and we don't have that. So I split it out negative 3 to positive 1 and negative 4 to use this part for completing the square. Okay, and now we have negative 4. So y equals to x plus 1 squared minus 4. Okay, we have a general formula for that. Y equals x minus h squared plus k. And in this form, h is the x coordinate of the vertex and k is y coordinate. So h and k is vertex. So you can see here we have positive 1 and negative 4. So h is minus h is positive 1, so h is negative 1 and k is 4. So the vertex point is negative 1 and 4. So far so good. And as I said before, we should use a table of values for 2 other points. The vertex is negative 1 and 4. Add 1 gives you 0. So substitute 0 in the equation. Y equals x plus 1 squared minus 4, which is negative 3. And negative 1 minus 1 is negative 2. So the answer would be exactly the same, negative 3. but if you like, you can calculate it. Negative 3 plus 1 squared minus 4. Negative 2 squared is, negative 2 minus 1 minus 4, negative 3, which is exactly the same. Okay, now I'm going to plot all of these 3 points. Okay, negative 1, negative 4, 0 and negative 3, negative 2, and negative 3. And this is our graph. And if I want to draw a line of symmetry, the equation of that is x equals negative 1, line of symmetry. So far, so good. So we have 2 strategies. The first one is using formula, and the second one is graphing by completing the square and convert any function, quadratic function, into this form. Okay. Now I'm going to teach you another strategies, which is really practical. But if you're working with exact numbers and need to plot precise points, the previous methods are more suitable. But if you just want to sketch the general shape of the parabola, using transformations can be quicker way that I'm going to talk about it now. So, using transformation to sketch quadratics. Okay. First one. Graphs of the form y equals x squared plus k, where k is constant, have exactly the same shape as the graph of y equals x squared. But every point on the graph of y equals x squared is translated k units vertically because k is a constant and it affects y directly. So, for example, if we have y equals to x squared minus 3, if I'm gonna sketch this one, first of all, y equals x squared is something like that, the general shape. And using y equals x squared, we have negative 3 as k. It means that you should move down 3 units vertically. So 1, 1, 2, and 3. So our graph is like that. In fact, we shift 3 units down. And this is y equals x squared minus 3. Sometimes k is a positive number, so you should go up vertically. Okay? And another one is y equals x minus h squared. Graphs of this form have exactly the same shape as the y equals x squared, but it is translated h units to the right or left, I mean horizontally. For example, y is x plus 5 squared. And you can see we have positive 5, and this number affects x, not y. So we should move horizontally to the right or to the left. So if I'm gonna sketch this, This is y equals x squared, and h here is -5 because we have negative h, which is +1. So h is -5, so we should move 5 units to the left. 1, 2, 3, 4, and 5. And exactly the same. Y equals to x plus 5 squared. So in two forms, if we have a constant like k, which is affecting y, so we should move up or down vertically, shift the graph of y equals x squared. But if we have a number that affects x inside the parentheses, so we should move to the right or to the left horizontally and shift the graph of y equals x squared. But we can have both of them. So in fact, we can combine these in one form. So for example, we have y equals to x minus 3 squared plus 6. So here we have a -3 and +6. So we should move or shift 3 units to the right and shift 6 units up. This is y equals x squared, and move 3 units to the right, 1, 2, 3, and shift 6 units up, 1, 2, 3, 4, 5, and 6. So we have a point here. In fact, +3 and +6 is coordinates of the vertex. So the vertex is here, and y equals x squared transformed to that point. So far, so good. And the last form is y equals a times x minus h squared plus k. So you can see we have a here. As I said before, a can be a positive or negative number. If a is a positive number, so we have upwards opening graph or opening parabola. And if a is a negative number, we have downwards opening parabola. Also, a can be bigger than 1 or less than -1. And in this situation, we have exactly the same y equals ax squared, but this is thinner than y equals x squared. I'm going to show you by an example. And if a is bigger than -1 and larger than -1 and less than +1, also not 0, y is wider than y equals x squared. Okay, I'm going to show you. We have an example. Y equals negative x minus negative 2, x minus 3 squared positive 5. Okay, so we should check for all of these three constants. This shows that we should reflect y equals x squared in the x-axis because A is a downward opening parabola, and because A, which is 2 here, is bigger than 1, something like that, so our graph is thinner than y equals x squared. So I'm gonna teach you how you can graph this. So this graph comes from y equals x squared. So the first thing is to draw x squared. And then we should make it wider and reflecting it in the x-axis. But before that, we need to find the vertex. And the vertex is positive 3 and positive 5. 1, 2, 3, and 1, 2, 3, 4, and 5 here, and we should reflect it because A is a negative number downwards, and then thinner. And this is y equals negative 2 x minus 3 squared plus 5. And how about this one? Negative 1/3 x plus 4 squared. So it comes from y equals x squared so this is y equals x squared, and it comes from x squared by using positive or negative 4 and 0 as the vertex. 1, 2, 3, 4. We should move 4 units to the left and 0 unit up. And then reflect it. And because we have 1/3 is less than 1, so we should make it wider than y equals x squared and reflect it in x-axis. So we have something like that. Because this is wider, the new y. Okay, I hope you enjoyed this video. See you in the next one. Bye-bye.